Hey Dragons, this is a video that I hope helps you with systems of linear equations. Well, what is a system of linear equations? Well, here's a good definition. A system of linear equations is made up of two or more linear equations, therefore they have to use the same variables, namely x and y, for which a common solution is sought. That means we're going to try to find a solution. There's no guarantee that there is one. There may be many. There may be one. But that's what we're going to be looking for. Let me give you some examples of linear systems. There's three linear systems. They're different colors. The first one over here is in red. If you notice, I have two equations. They're both in y equals mx plus b form. And they use the same variable, x and y, in each one of them. Two equations, two variables, both in linear form. This is a system. The blue guys over here, if you notice, bonus points if you remember what form this is. That's right, it's standard form, ax plus by equals c. So we have two equations with the same two variables. This is a system of linear equations. The last group over here is also a system of linear equations. Okay, this again is a good review. This is a horizontal line. So this is a line in standard form, and so there is it is a system. So let's look at these guys again in context of the solution. So what is the solution to these guys? Remember, we're seeking a common solution. We want an ordered pair that makes both equations, you know what goes here? I bet you do. It's the word true. We want an ordered pair, an x and y, that will make this first red equation true and this second red equation true. The same ordered pair has to work in both of these equations, and they both have to make it true. Okay, whatever ordered pair over here makes this true, it has to work in the first guy and then in the second guy. Same thing over here. The ordered pair has to work in both the first and the second guy. It's got to work for both. It's all or nothing, folks. So, as we take a look, I'll tell you right now, let's look at the red one. The solution for this is going to be 1, 3. Okay? Now, how do I know that? Well, let's come up here. My x value is 1, and my y value is 3. So if I come over here and substitute in the x and the y in the appropriate place in the first red equation, I get 3 equals 1 plus 2. And that is true. Okay? Now, working in one equation is not enough. It has to work in both. So we take the same ordered pair, the same x value, it's going to go right here, it's going to be multiplied by 2, the same y value is 3, fill in everything else, and we ask ourselves, is it true? Is 2 times 1 plus 1 equal to 3? And the answer is yes. You see, this ordered pair makes both of these guys true. That makes it a solution. The solution for the blue guys is 2, 6. X of 2, y is 6. If we come over here, 3 times 6 is 18. Negative 4 times 2 is negative 8. Add them together, you get 10. Works in the first guy. Let's see if it works down here. 7 times 2, that's my x value. My y value is still 6. That's 14 plus 6, and shazam, what do you know? It works there. So this guy is a solution to this. And the solution to this last system is going to be 4, 5. So we have an x of 4, and we have a y of 5. So 3 times 4 is 12, plus 5 is 17. It works. Now, I know what some of you are saying. Some of you are looking at this. Ms. Malik, what's the deal? There's no x. I don't see it. Consider this. can I rewrite this as 0 times x plus y equals 5? Are these two guys right here the same equation? I hope you answered yes. Okay? Because if I multiply something by 0, it's going to wipe it out. So if I put that x right there, I'm now doing 0 times 4 plus 5 equals 5. Well, 0 times 4 is 0, plus 5 equals 5. Hey, guess what? It works in that guy too. That x is that one. So that's my solution. Now, we're really going to be focusing on the red and the blue. A little patriotic theme here. Okay? If you run across these, don't freak out. I mean, they work the same way. Now, there are three possibilities when we're graphing lines. And we talked a little about this in the first semester. Okay? But now, if we have two lines, they could simply cross at a single point. Right there. That's the only place they cross. Okay, that's one possibility, and that's going to be our main focus for today, is the intersection where we have one solution, this point right here. Now we could have this situation right here. You know these as parallel lines. Well, are parallel lines ever going to cross? No, and they're not going to have a solution. So if you run across parallel lines, and you will the second day of this study on system of linear equations, we're simply going to write no solution because they're not going to cross. Now the other situation is where the two equations form the same line. How many points do these coinciding lines share? They share all of them. So there's going to be an infinite number of solutions. So hopefully that has shaken a few cobwebs off of what we learned the first semester. But again, today we're focusing on the system where it crosses at one solution. We want to find that one point. Okay? So enough of my barbecue skewers right here. So as we take a look at the next thing, we need, as algebra teachers, we talked about this, we need each Round Rock Algebra 1 student to be proficient in multiple representations of linear systems. So I kind of made a little flow chart here. I'm probably going to flow off of the screen, but we'll make it work, okay? So let me come up here. We need for you guys and gals to go from a word problem, into equations. And I accidentally left it off when I was typing it up. It's not one equation. We need two or more. We're going to focus on two equations, okay, using the same variables. And once we get an equation, we'll be able to go to the graph. And then once we do our graph, we'll be able to go to a table. Okay? Now you may say, would you hide behind these papers, Miss Mahalik? Well, once we come down here, once we're able to take the verbal and go to an equation, we have our calculator will help us. And our calculator, what we're going to do are, you know what our buttons are right here, we're going to put our first equation in y1 equals, and then we're going to put our other equation in y2 equals. So we're going to have a place for both of our equations to go in our calculator. Calculator good. Calculator good. All right. And so if we do that, we can now graph it. What are the keystrokes there? These are my little keys. Get it? So we're going to hit graph, and we're going to need the data to fit. So we're going to hit zoom. That's on the top row. And we're going to do zoom fit. So the keystroke would be graph zoom 0, and then that should focus in on the intersection if it occurs. And if we have our table now, you remember how we get to our table? I hope you do. Please say you do. All right, it's going to be second and graph. All right, so we have a good thing there. Now, we are looking for solutions, right? So where do my solutions come from? Well, the solution is what I did with my little skewer sticks here earlier. It's where the ordered pair, it's the ordered pair where the lines cross or intersect. Okay, so that's what we're looking for. And then when we go to the table, we're going to have a table where we have two outputs. All right, and we're looking for when the outputs are the same. So how would that look like? I took a little screenshot of an example right here. When you go to your table, as you look at this right here, you need to realize that I have two different equations. I have one y sub 1 and y sub 2. But they share the same ordered pair. You need to be able to look at the screen and say, hey, I have a common solution of 2, 3. All right. So as we quickly take a look at this, we're done. That was the 10-minute timer. I'm going to start another video with an example of what we just talked about. I'm going to use that flow chart. So let's go to our second video.